Hello everyone, you are listening to Professor Rajendra Tadakhe, Department of Mechanical Engineering, Marathwada Mitra Mandal's College of Engineering, Karvenagar, Pune. So in the previous lecture, we have started with the velocity analysis of the mechanism. Basically, there are two different approaches for the velocity analysis of the mechanism. Those are analytical and graphical. So in yesterday's lecture, we have started with the graphical approach for the velocity analysis of the mechanisms, and in that we have seen the instantaneous center method for the velocity analysis of the mechanism. So before we proceed further, we will recapitulate important part from the previous lecture. So the important part is what exactly instantaneous center is. So in short, we can define the instantaneous center is a point about which the body or a link or an element is having pure rotational motion at a given instant. So this is very important, at a given instant only. Then after this, we have seen the different types of instantaneous centers. So those are fixed instantaneous center, permanent instantaneous center, neither fixed nor permanent instantaneous centers. So these are the three different types of the instantaneous centers we have seen. Then after this, we have seen how to calculate the total number of instantaneous centers for the given configuration. And finally, we have tried to understand the general procedure to locate the instantaneous centers for the given mechanism. So in today's lecture, we will see another problem of the slider crank mechanism for the velocity analysis by using instantaneous center method. So let's move to the problem. So here is the problem statement. A slider crank mechanism is as shown in figure 1. The crank of length 6 cm rotates at a uniform speed of 300 rpm. The length of the connecting rod is 25 cm when the crank has turned by 30 degree from its inner dead center. Locate all the instantaneous centers of the mechanism and find the angular velocity of the connecting rod and also the velocity of the piston. So this is the given configuration, and for this given configuration all the dimensions are mentioned. So this AB is the crank whose dimension is given as 6 cm, that is length of the crank is 6 cm. Then BC is the connecting rod whose length is mentioned as 25 cm. Then the angle of the crank from the inner dead center is given as 30 degree, and this is a slider. So let's move to the solution. So first of all, we have to write a given data. So write a given data first. Speed of the crank AB is given, which is 300 rpm. Then length of the crank AB is mentioned, which is 6 cm. Then length of BC is mentioned, that is 25 cm, which represents the length of connecting rod. Then we have to locate all the instantaneous centers and we have to find the angular velocity of connecting rod and the angular velocity of the piston. So after this, the very important step we have to perform is we have to draw the configuration diagram for the given problem. So here we are provided with the slider crank mechanism and the dimension of the crank, connecting rod and the position of the crank with respect to the inner dead center is mentioned. So accordingly we have drawn this configuration diagram. So crank AB length is 6 cm, its angle from the inner dead center is 30°. Then the length of connecting rod is mentioned, which is 25 centimeter. So in this way we have drawn the configuration diagram, but many students get confused while drawing the configuration diagram. So please make sure that you are drawing the correct configuration diagram, because your entire things depends on the configuration diagram. If you make a mistake while drawing the configuration diagram, then your entire problem will go wrong. So I will explain the configuration diagram in more detail. So first of all, what we have to do while drawing the configuration diagram of the slider crank mechanism, first draw this dotted line, which is called as line of stroke or the line of action. So this is a line of action or the line of stroke along which the slider moves. Then fixed any point A on this dotted line. Then measure an angle of 30° and mark a arc of radius 6 cm from point A. So we'll get point B. So once we get the point B, then we have to locate the point C on the line of action. So now it is very easy. Take a radius of 25 centimeter and mark the arc on this line of stroke from the point B. Then we'll get point C. So in this way we will complete the configuration diagram. So once the configuration diagram is completed, then we have to move to the next step, that is we have to calculate the total number of instantaneous center for the given mechanism. So for that we have to count how many number of links this mechanism is having. So start counting the number of links. So this is fixed link 1. So here one important point, all the fixed link we count as a 1. So this one and this one together it is link number 1. Then crank AB is link number 2. Then BC, that is connecting rod, is link number 3, and then the slider is link number 4. Yes, we have total 4 number of links for this configuration. So now the next step is we have to calculate total number of instantaneous centers. So we are having a formula to calculate the total number of instantaneous center for the given configuration, and the formula is capital N is equal to small n into n minus 1 divided by 2. As explained earlier, this capital N stands for the number of instantaneous centers and the small n stands for the total number of links. So here we are having total 4 links, so put the value of small n as 4 and calculate the number of instantaneous center for the given configuration. So we have put the value of n 4. So finally we get the value of capital N as 6. So for this configuration we are having total 6 instantaneous center. So once we get the total number of instantaneous center for the given configuration, then we have to make the list of all the 6 instantaneous center. So for that we have to make this table. So in the first column we have to write all the link numbers. So first column is of links. So how many links here we are having? 4. So start from 1, 2, 3, 4. Then we have to write the instantaneous centers. So how to write this instantaneous centers? First go to the link number 1, then I. Keep 1 as fixed and change the second digit. So it is I12. Then next I13. 1 is constant. After 2, 3. So it is I13. Next is I1 is constant. After 3 we are having link number 4. So it is I14. So similarly now go for the link number 2. Keep 2 as a constant and keep on changing the next digit. So here we are having I, 2 constant, then I 2 3. Next again 2 is constant, after 3 4. So it is I 2 4. So similarly go to the link number 3. So we get I 3 4. So after 4 there is no link, that is why we are getting only I 3 4. And after link number 4 there are no links, that's why it is blank. So here we have made the list of all the 6 instantaneous centers. Now it's time to locate the instantaneous centers in the given configuration. So as we have seen in the earlier lecture that we are having 3 different types of the instantaneous centers. Those are fixed, permanent, neither fixed nor permanent. So out of these 3, the first 2 instantaneous centers can be located by observation. So we'll locate fixed and permanent instantaneous center by observation. So this I1 2. So here it is link number 1 and here it is link number 2. So at point A we are having the instantaneous center I1 2. So here it is I1 2. So we'll mark, as we have located this I1 2, so we'll mark in the table that I1 2 is located. Now next, link number 2 and link number 3, they are connecting to each other at point B. So at point B we have the permanent instantaneous center, which is I23. So we have located I23 by observation. So we'll mark it in the table. So I23. So after this we are having the connection between link number 3 and link number 4, that is between connecting rod and the slider or a piston. So again it is a I34 and which is permanent in nature. So it is I34 at this location. So again mark it in the table I34. Then this I13 and I24, these are neither fixed and nor permanent in nature, but this I14 is fixed in nature. So where to locate I14? So if you observe, 1 is the link number fixed and 4 is the slider. So this I14 will be at infinity, because what we are assuming here, this slider is performing a circular motion about the circumference, along the circumference of the circle whose radius is at infinity. Therefore the instantaneous center I14 will be at infinity. So that is why we are writing it is at infinity. So along this line I14 will be there and it is at infinity. So this is the very important. So whenever you come across the slider, then the instantaneous center is at infinity. But the condition is that slider must move on a straight line. If it is a curvilinear surface or the slider is moving on the curvilinear path, then the instantaneous center will lie on the center of the curvature. So we have located I14, so we'll strike it out from the table. Okay, now we have left with the I13 and I34, which are neither fixed nor permanent in nature. So we have to locate these 2 instantaneous center. So for that, first of all we will draw a circle. Now we have to mark the point on the circle equal to the number of links in the given configuration. So how many links we are having in this configuration? 4. So mark the 4 different points on the circumference of this circle. So here it is point 1, here it is point 2, here it is point 3 and here it is point 4. Now we have to connect all these points, but those connections are having certain meaning. So when I join I12, so this is representing the instantaneous center I12. So it is I12. Now join 2 3. So again this 2 3 is nothing but it is I23. Then join 3 and 4. So again 3 and 4, which represent the instantaneous center 3, 4. Then join 1, 4. Again it is representing instantaneous center 1, 4. Now we have to locate I13. So now search for the point 1 and point 3 in this. So here we are having point 1 and here we are having point 3. So connect these 2 points by a dotted line. So we have connected these 2 points by a dotted line. Now this dotted line is representing the instantaneous center I13. So this instantaneous center I13 we have to locate in the configuration diagram. So for that we have to take the reference of this. So when we are connecting 1 and 3, so here we are getting the 2 triangles, that is triangle 1, 2, 3 and triangle 1, 4, 3. Now here we are having I12 and here we are having I23. So here it is I12 and here it is I23. So draw the line through this 2 instantaneous center through I12 and I23. Yes, we have drawn the line through instantaneous center I12 and instantaneous center I23. So now it is intersecting to this vertical line at some point. Okay, so we will come to this part later on. Because why it is intersecting? The reason is when we go for the second triangle, we are having instantaneous center I14 and instantaneous center I34. So here on this line we are having 1, 4 at infinity and 3, 4 at this point. So that is why both the lines are getting intersect at this point, and at the intersection we get the instantaneous center I13. So we have located the instantaneous center I13. So we'll mark it in the table. Now next we will move to the instantaneous center I24. So exactly the same procedure we have to follow for the location of I24. Connect point 2 and 4 by dotted line. Now this dotted line is representing the instantaneous center I24. So we have written here I24. Now again it is making a 2 triangles, that is triangle 1, 2, 4 and triangle 2, 3, 4. So let's take the instantaneous center I12 and I14. So 1, 2, here it is 1, 2 and here it is I14. So in this case we can slide this vertical line or I14 at infinity along this line, but it should be perpendicular to the line of stroke. Okay, so we have transferred it to at point A, but again it is I14 at infinity. Now next one is we are having 3, 4 and 2, 3, 3, 4 and 2, 3. So draw the line through 3, 4 and 2, 3. Then it will intersect to this vertical line. So the intersection is nothing but the instantaneous center I24. So we have located instantaneous center I24, which is neither fixed nor permanent in nature. So in this way we have located all the instantaneous center for the given configuration of the single slider crank mechanism. Now the next part of this, or we can say the important part of this story, is we have to calculate the angular velocity of the connecting rod, that is for link BC, and the velocity of piston, that is for the slider C. So for this, to calculate the angular velocity of the connecting rod BC, we will use the angular velocity ratio theorem. So according to the angular velocity ratio theorem, we can write the angular velocity ratio of link x to the angular velocity of link y is equal to I1y upon I1x into Ixy upon Ixy. So here x is 2 and y is 3. So that's why we are writing omega 2 upon omega 3. So here omega 2 stands for the angular velocity of crank and omega 3 stands for the angular velocity of the connecting rod, which we have to find. So here the value of y is 3, so here I13, x is 2, so I12 into x and y 23, so it is I23 upon I23. So the next step is we have to get the value of omega 3, but before that we must know the value of omega 2. So to get the value of omega 2 we are provided with the RPM of the crank. So by using the formula omega 2 equal to 2 pi n by 60, we can get the value of omega 2. So omega 2 we are getting 31.416 radian per second. So once we get this value, we can put this value in this equation. So to calculate the angular velocity omega 3 of the connecting rod, omega 2 upon omega 3 is equal to I13 upon I12 into I23 upon I23. So here omega 2 value is 31.416, which we have substituted upon omega 3, that is the angular velocity of the connecting rod we have to find out. Then we have to go to the configuration diagram and measure the distance between I13 and I23. So that distance comes 28.6 centimeter or 28.6 units, and the distance between I12 and I23. So this I12 and I23. So I12 is at point A and I23 is at point B. That is corresponding to the length of crank, which is 6 centimeter or 6 units. So from this we get the angular velocity of the connecting rod omega 3 is equal to omega BC is equal to 6.6 radian per second. So here is our answer. Now we have to calculate the velocity of the piston. So here we just have used the simple formula that V is equal to R omega. So V is equal to R omega. So radius is I13, I34 and into the angular velocity of the connecting rod. So this distance I13 and I34 we have to measure from the configuration diagram, that is 17.2 into omega 3, which we have calculated in the earlier step. So 17.2 into 6.6, which gives the velocity of piston as 113.36 meter per second. So here is the complete solution of the problem. Thank you. So in our